When someone asks, "Why does fire burn?" it sounds almost childish. It's the kind of question we assume was answered somewhere between learning not to touch the stove and passing basic science class. Fire burns because it's hot. End of story. Except that answer doesn't actually answer anything. It just replaces one familiar word with another and gives us the comforting illusion that we understand. Richard Feynman loved pointing this out, not to embarrass anyone, but to expose something deeper about how we think. We're very good at naming things. Naming gives us a sense of control. The moment we attach a label, we feel the question has been handled. But naming is not explaining. Saying fire burns because it's hot is like saying a clock works because it tells time. It feels complete only because we've stopped asking questions at a socially acceptable point. Feynman's insight was that the real difficulty isn't the complexity of nature. It's the assumptions we bring into the conversation. We think we're asking for a simple explanation, but what we often want is a translation into familiar terms, and the universe doesn't owe us familiarity. When you keep asking why, eventually you hit a layer where everyday language stops working. Not because science has failed, but because our intuitions were never built to operate there. So what's actually happening when fire burns you? That question immediately forces us to confront an uncomfortable truth. The sensation of burning is not a property of fire at all. It's an experience produced by your nervous system. Fire doesn't know it's hot. Atoms don't care. The pain, the urgency, the instinct to pull your hand away, those are biological interpretations, layered on top of physical processes. Already the question has shifted from fire to perception. And this is where Feynman gently dismantles our confidence. Because now the question isn't just why does fire burn? It's what do we even mean by burn? Do we mean damage to tissue, energy transfer, chemical reactions, neural signals? Depending on where you stop the explanation, you get a completely different answer. And none of them are wrong. They're just incomplete. This is deeply unsettling if you're used to thinking of reality as a set of solid, self-evident facts. We like clean explanations with firm boundaries. But nature doesn't organize itself around our comfort. It's layered. Every why opens into another how, and every how rests on assumptions you didn't know you were making. Feynman never treated this as a failure of understanding. He treated it as an invitation. The moment you realize that a simple question has no simple answer, you're no longer just memorizing facts. You're participating in the process of understanding. You're learning where language breaks down, where intuition misleads, and where deeper explanations begin. Psychologically, this is threatening. We want certainty. Philosophically, it's liberating. Because if even fire, something ancient, primal, and familiar, turns out to be more subtle than it appears, then the world is far richer than our first impressions. The mystery isn't that we don't know enough. The mystery is that we ever thought we did. Feynman's point wasn't to say, you don't understand fire. It was to say, look how deep the question goes. The simplicity of the question is precisely what makes it powerful. It exposes the limits of explanation, the structure of knowledge, and the strange fact that reality doesn't come pre-packaged in human-sized answers. And once you see that, you can't unsee it. Because if a question this simple isn't simple at all, then perhaps the world is not built out of obvious truths, but out of layers waiting for you to notice them. Once you move past the idea that fire is simply a thing that hurts you, the next assumption to fall apart is even more deeply rooted, the belief that burning is a form of destruction. We talk about fire as if it erases objects from existence. Wood is consumed, paper is destroyed, something solid becomes nothing. But that picture, while emotionally satisfying, is fundamentally wrong, and Feynman would insist we correct it, not because it's poetic, but because it reshapes how we understand reality itself. When something burns, nothing vanishes. Not a single atom is lost. What changes is the arrangement. The atoms that once sat neatly in long chains inside wood are suddenly offered new partners. Oxygen, floating invisibly in the air, is eager to join the dance. Burning is not violence, it's chemistry moving at high speed. A negotiation, not an annihilation. This matters because it challenges how we instinctively think about loss and transformation. Fire feels final. Ash feels like an ending, but in physical terms, burning is one of the clearest demonstrations that nature never throws anything away. The carbon in the smoke, the heat in the air, the light in the flame, all of it existed before the match was struck. Fire merely unlocks what was already there. Feynman loved pointing out that energy is not created by fire. The energy released was stored in the bonds between atoms, quietly waiting. The flame is not a source of energy, it's a messenger. It's what we see when those bonds rearrange themselves into a more stable configuration. The brightness, the heat, the dramatic movement. It's the universe signaling that something has become simpler, more comfortable, more probable. This idea quietly dismantles another illusion that matter is static unless acted upon. In reality, everything is already in motion, already under tension. Wood is not calm, gasoline is not peaceful. They're structured in a way that can be undone. Fire doesn't force atoms to change, it gives them permission. Psychologically, we tend to associate burning with destruction because we experience it as loss. The book is gone, the house is gone. But physics doesn't care about our inventory. From the universe's perspective, nothing meaningful has been destroyed. The atoms are still there, obeying the same rules they always have. What's changed is their story. And this is where Feynman's thinking becomes quietly philosophical. If burning is rearrangement rather than destruction, then permanence was never real to begin with. The stability we experience in everyday objects is conditional, temporary, a pattern that holds only under certain circumstances. Fire reveals this not as an exception, but as the rule. Even the heat you feel, the part that seems so aggressive, is simply energy redistributing itself. It's the cost of change. When atoms settle into tighter bonds, the excess energy has to go somewhere. It escapes as motion, as radiation, as light. Fire isn't cruel, it's efficient. Once you see burning this way, it becomes impossible to think of fire as a villain. It's a process that exposes the hidden bookkeeping of nature. Nothing wasted, nothing erased, just transformation, played out fast enough for our senses to notice, and that realization should unsettle you just a little, because if fire doesn't destroy matter, then maybe destruction itself is a story we tell. Not a fundamental feature of the universe, but a human interpretation layered on top of endless rearrangement. Once you accept that burning is not destruction but rearrangement, the next question almost asks itself. If nothing is being destroyed, then what exactly are we feeling when something burns? This is where Feynman would smile, because the answer pulls the rug out from under one of our most trusted intuitions. We think we feel heat as a thing, as a substance flowing into us. But heat isn't a thing at all. It's motion. At the deepest level accessible to explanation, temperature is a measure of how violently atoms and molecules are moving. When something is cold, i.e., particles are moving more slowly. When it's hot, they're jostling, vibrating, colliding with greater energy. Fire doesn't carry heat like a bucket carries water. What it does is set nearby atoms into faster motion, and those atoms, in turn, pass that motion along. When your hand gets too close to a flame, nothing mystical happens. No fire essence leaps into your skin. The atoms in the air, already energized by chemical reactions, crash into the atoms in your hand. Those atoms begin vibrating faster than the delicate structures in your cells can tolerate. Proteins start to unravel. Nerve endings send urgent signals. Your brain interprets that rapid atomic chaos as pain. And here's the crucial point. The pain is not in the fire. It's not even in your hand. It's an interpretation constructed by your nervous system. The universe is doing what it always does, particles obeying simple rules of motion. The suffering arises only when that motion crosses the limits of biological tolerance. Feynman found this endlessly fascinating because it shows how far removed our experience is from the underlying reality. We don't feel atoms moving. We feel meaning. We feel threat. We feel damage. Evolution trained us to react quickly, not to understand accurately. Heat to us is danger, but to physics it's bookkeeping. This gap between reality and experience is where most confusion lives. We speak as if heat flows, accumulates, attacks. But these are metaphors, and they hide the truth. What's actually happening is countless microscopic collisions, all obeying the same laws whether they warm your hands or cook your skin. Philosophically, this should make you pause, because it means one of the most immediate sensations you know, the feeling of burning, is not fundamental. It's an emergent signal, a translation layer between atomic motion and conscious awareness. The world itself is indifferent. Your experience of it is not. And yet, this doesn't make the experience less real. It makes it more extraordinary. Out of blind particles and simple interactions emerges something as vivid and urgent as pain. Meaning arises where none exists at the atomic level. Fire doesn't intend to harm you. Your nervous system assigns that meaning because survival depends on it. Feynman often emphasized that understanding this doesn't drain the drama from life. It deepens it. The fact that simple laws, repeated trillions of times, can generate sensation, awareness, and fear is not disappointing. It's astonishing. Once you grasp that heat is motion, the flame changes character. It's no longer a malevolent force. It's a region of space where energy is being redistributed at extraordinary speed. Your body reacts not because fire is evil, but because life is fragile. And that realization leads to a subtle but powerful shift in perspective. What you experience as burning pain is not the universe acting against you. It's the universe doing exactly what it always does, while your biology struggles to keep up. By this point, the idea that fire is a thing should already feel unstable. We've seen that it doesn't destroy matter, and it doesn't contain heat the way an object contains mass. So now we're forced into a deeper realization, one that Feynman delighted in because it cuts straight through how our minds like to organize the world. Fire is not an object at all, it's an event. We instinctively treat fire as something you can point to, hold a mental picture of, maybe even imagine scooping up if physics allowed it. But what you're actually looking at when you see a flame is a temporary process made visible. It's energy in transit, a momentary display of atoms rearranging themselves and shedding excess energy as light and motion. The flame has no independent existence. Take away the fuel, the oxygen, or the conditions that allow the reaction to continue, and the fire disappears instantly. Not because it was killed, but because the process can no longer run. Fire is closer to a verb than a noun. It's something matter is doing, not something matter is. Feynman would emphasize that this distinction matters because our intuition is built for solid things, rocks, tables, bodies. Processes feel abstract to us. We struggle to take them seriously, and yet reality is dominated by processes. Weather isn't a thing. A wave isn't a thing. A flame isn't a thing. They are patterns that persist only as long as conditions allow. What makes fire especially deceptive is that it's visible. We see shape, color, movement, and we assume substance. But the glowing region you call a flame is mostly hot gas and light. The bright yellows and oranges aren't the fire itself. They're atoms emitting light as their electrons briefly jump between energy states. You're watching energy announce itself before disappearing into the surroundings. Psychologically, this is unsettling because it means the most dramatic part of fire, the flame, is not the cause of anything. It's the byproduct. The real action is invisible. Chemical bonds breaking and forming, oxygen combining with fuel, energy being released because the new arrangement is more stable than the old one. Once again, Feynman's lesson isn't just scientific, it's philosophical. We have a habit of mistaking appearances for causes. We focus on what we can see and ignore what actually matters. Fire punishes that habit. The visible flame feels powerful, but it's only echo of deeper processes we can't directly perceive. And this realization should ripple outward. How many other things do we treat as solid, fixed entities when they're really temporary patterns? How many things we fear or revere are just processes unfolding according to impersonal rules? Fire feels alive. It moves, it dances, it consumes, but it has no intention, no hunger, no will. The sense of agency we project onto it is entirely our own. The universe is not trying to burn you, it's simply following the path of least resistance, releasing energy where it can. Understanding fire as a process also dissolves the idea of control in an interesting way. You don't control fire by commanding it, you control it by controlling conditions. Remove oxygen, limit fuel, alter temperature, and the process stops. This is true not just of fire, but of countless systems in nature and society. Change the conditions, and the behavior changes. Once you stop seeing fire as a thing and start seeing it as energy briefly made visible, the world looks different. Solid objects feel less permanent. Events feel more fundamental. And you begin to realize that what you thought were stable features of reality are really ongoing negotiations between matter and energy. Fire is not something that exists. It's something that happens. And the moment you grasp that, reality becomes far less solid and far more alive. By now, a pattern should be emerging, and it's not just about fire. At every step, the D per explanation has moved farther away from what your senses report. The more accurately we describe what's happening, the less it resembles what it feels like. This is the point where Feynman would slow down and make sure you're paying attention, because this is where our most reliable tools, our eyes, our skin, our intuition, quietly betray us. When you look at a flame, you see color, shape, movement. When you touch it, you feel heat and pain. These experiences feel direct, immediate, and authoritative, but none of them are telling you what fire is. They're telling you how your nervous system reacts to certain conditions. Your senses are not windows onto reality, they're filters, evolved to keep you alive, not to reveal truth. This is a deeply uncomfortable idea. We like to believe that seeing is believing, that direct experience is the gold standard of knowledge. But physics keeps showing us the opposite. The colors of the flame depend on electron transitions you can't see. The heat you feel depends on molecular motion you can't sense directly. Even the solidity of the world, the sense that objects are there, is mostly empty space held together by forces that don't resemble anything in daily life. Feynman often pointed out that the universe is under no obligation to be intuitive, and yet we constantly demand that it be. When it isn't, we blame the explanation rather than our expectations. We say it's too abstract or too removed from reality, when in fact it's closer to reality than our senses have ever been. Psychologically, this creates tension. We trust what feels real. Fire feels dangerous, aggressive, alive. But physics describes something utterly indifferent. Particles following simple rules, no intention, no awareness, no concern for human meaning. The conflict between these two perspectives, the lived experience and the underlying mechanism, is not a flaw in science. It's a feature of being human. Philosophically, this forces a reckoning. If your senses don't tell you what's actually happening, then certainty becomes fragile. Knowledge becomes layered. Truth is no longer something you simply see, but something you infer, test, and revise. Fire becomes a lesson in epistemology, a demonstration of how we know what we know. And yet, Feynman never suggested abandoning your senses. He suggested understanding their limits. Your pain response is real and vital. Your fear of fire is rational. But mistaking those responses for explanations is where confusion begins. The map is not the territory, and sensation is not understanding. This is why science feels to many people like it destroys meaning. It strips away the familiar story and replaces it with something colder, more mechanical. But Feynman argued the opposite. Once you accept that your senses are translators rather than judges, a deeper kind of wonder emerges. You realize that beneath every ordinary experience lies an invisible world more intricate than anything you could have imagined. Fire teaches this lesson brutally and efficiently. What you see is not what's happening. What you feel is not what's fundamental. Reality operates beneath perception, and perception is a survival tool, not a truth detector. If that feels unsettling, it should. Because the moment you stop trusting appearances, you don't lose reality. You finally begin to approach it. At this stage, there's a temptation to feel that something has been taken away. Fire no longer feels mysterious in the old way. It's no longer a living force or a destructive spirit. It's atoms, energy, motion, probability. And some people hear that and think, so that's it? The magic is gone. Feynman would have strongly disagreed. In fact, this is exactly where he thought the real wonder begins, because what understanding fire actually does is replace a shallow mystery with a deep one. Before, fire was mysterious because we didn't look too closely. Now it's mysterious because we have. The explanation doesn't shrink the universe, it opens it. It reveals layers beneath layers, all governed by simple rules that somehow give rise to heat, light, danger, beauty, and meaning. Feynman often pushed back against the idea that science makes the world dull. He argued that ignorance isn't wonder, it's just ignorance. True awe comes from seeing how much is going on beneath the surface of something ordinary. A flame isn't less beautiful once you know its electrons dropping between energy levels. It's more beautiful because now you're seeing not just the glow, but the story behind it. Psychologically, this matters because humans crave meaning. We want the universe to feel significant, purposeful, alive. When we hear that fire has no intention, no awareness, no desire to burn, it can feel alienating. But what replaces that story is far more extraordinary. A universe where blind rules produce complexity, where simple interactions give rise to experience, where understanding is possible at all. There is something profoundly humbling in realizing that the same laws governing a flame also govern stars, cells, and thoughts in your own brain. The fire doesn't care about you, but the fact that you can understand it, even partially, is astonishing. You are a piece of the universe that has learned to ask questions about itself. Feynman believed that knowledge doesn't drain the world of emotion, it changes the emotion. Fear becomes respect, confusion becomes curiosity, mystery becomes depth. The flame stops being a symbol of destruction and becomes a symbol of connection between chemistry and biology, physics and psychology, perception and reality. Philosophically, this is the quiet revolution hiding inside the question, why does fire burn? It teaches you that reality is not built to match your intuitions, that explanations don't end where comfort begins, and that the more you understand, the stranger and richer the universe becomes. And notice what hasn't happened. The fire is still hot, it's still dangerous. Understanding doesn't protect you from it. Knowledge doesn't replace experience, it contextualizes it. You still pull your hand away, you still respect the flame. But now, layered on top of that instinct is insight. Feynman never promised that understanding would make life easier. He promised it would make it more honest. The universe isn't simpler than we think, it's more subtle. And fire, in its brutal clarity, forces us to confront that fact. So in the end, the question, why does fire burn, doesn't just teach you about fire, it teaches you how explanations work, how perception misleads, and how deeply structured reality really is. It teaches you that the world is not only stranger than you imagine, it is stranger than you can imagine, and still, somehow, open to understanding. And that realization doesn't destroy reality, it reveals it.